So, hello dear students, very good morning. I hope you all are up for the mathematics classes. So, as I heard that you all are facing problems on doing the questions which are based on functions. That means as function, I have taught you what is it. That is, there are many types of functions. That is one, onto, many, one, into, which are also called as injective, bijective, surjective and so on. So I have come up with some criterias or the steps which you need to follow while doing the questions. So I will take some questions here. That means those are your doubts only. I will explain you how you have to go step by step for solving those questions. So you have to show your thorough interest and also the sincerity here, and to understand these things are not written in the book. Okay, so whatever I'm going to explain, you have to focus. So let's start. Okay. So dear students, before doing the questions, I just want you to understand the types of function one more time. As I counted, there are 4 types of functions: one, onto, many one, into. So we need to just precisely understand the meaning of these 4 types of functions. So I'm starting with the very first one, that is one function. Okay, so let me just explain you with the example so that it would be more clear to you. So one function, if we are seeing, that means if I'm taking a b c here and I'm taking a b 1 2 3. So if you can see, I'm making a mapping from x to y. There is some set x having value a, b, c and y having value 1, 2, 3. Then, and if your mapping in is such that all the elements of this x are related to y, that means all the elements of x have some image in y. So this is the perfect example of one function. So we can say that a function is one or is said to be one if and only if different elements of x have different images in y. This is an example of one function. Now coming to the onto function says that a function is said to be onto function if and only if you might have seen IFF in the definition. Okay, so that IFF means if and only if. Okay, so the function is said to be onto if and only if the different elements of y have different elements in x. That means this is totally the opposite of one function. That means onto function we have to go in the reverse order. Okay, so that is why I'm saying that different images, you can define onto function as different images have a different element or different elements. Okay, so that is the condition. So you can take this also as your example for onto case. This is totally invert of one. Now coming to the into function says that, what does the into function says? That at least like one element should be left here. That means, so for example, I'm drawing 1 a b c here, 1 2 3 4. A is related to 3, b is related to 1, c is related to 2. Now you can say you have this image, it has no element here in this x, so this is a kind of into function. Okay, then many one function says that element can have multiple images. Okay, if an element has multiple images, okay, no, sorry, I just say for example, Okay, if we keep only 1, the two element, that means, can you see many one, that these two elements are having the same image here. So this is the example for many one function. Okay, because this a and b are having the same image. I told you the two elements can have same image, but an element cannot have two images. Okay, an element cannot have two images, but two elements can have a single image. Oh, okay. And at last there is one more, that is 1 1 on 2. What do you mean by 1 1 on 2? If you have 1 2 3 x y z, okay, so this is 1 1 also, this is on 2 also, so this is also called 1 1 correspondence. Okay, this is also called 1 1 correspondence. Please understand here, you can write there. Now they have one more name, that is 1 1 is called as injective, onto is called as surjective, and 1 1 onto is called as bijective. You have to remember the names. Now how we will apply this concept in the question? This is the main the main challenging thing for the students. So let me just tell you, you don't have to worry for anything. I will make all the questions and all the concept easy for you. Okay, so now let's start with the questions. I hope you have understood this. I have already explained in the previous videos, so if you have seen them thoroughly, you can surely understand the questions as well. So let's start with the questions now. So hope you understood the definitions. Now let's dive into this exercise. Now I'm taking very easier question number 16th of the exercise, which says, if you have set A as 1 2 3 elements and B as 4 5 6 elements, and you have a function having some relation and they are related as 1 4 2 5 3 6. Now there is some kind of relation. How this 1 4 has been written, 2 5 and 3 6, we don't have to go into that relation. We have a direct function here like this, and we have to prove that f is a 1 1 function, but it is not an onto function. So this question can be clearly solved with the help of mappings. Okay, how mapping we have to draw? The two sets, this is A and this is B. 1 2 3, so 1 2 and 3, and here 4 5 6 7, just write 4 5 6 7. Then 1 4, 1 is related to 4 with some relation that I already told you, that doesn't matter to us. 2 is related to 5 and 3 is related to 6, and we know that from here, with the help of definition which I have explained you just a minute before, so with the help of that we can easily distinguish that this type of function is which one? 1 1 onto into many one, or the 1 1 onto. So we just need to prove that it should be 1 1 but not onto. So 1 1. The definition of 1 1 says a function is said to be 1 1 if and only if different elements of this set must have different elements in. So here different elements have different images. So the definition, the statement of the 1 1 function is satisfied that these three elements have different images. So this is f is 1 1 function. This we have proved. You only have to write the definition. See, if you are thinking that how to write, how to present the solution, no worries. You can make this mapping, write the definition of 1 1, and you say clearly f is a 1 1 function. That is enough. Okay. Now coming to the onto function, we know the definition of onto function, which is then opposite of the 1 1 function. So 1 1 says, onto says a function is said to be onto if and only if the different elements in the set this B must have different elements. So here can you see this 7 is remaining. This image, or if you consider this is element, so this element has no image in this set. So clearly it is not satisfying the onto function definition, hence it is not an onto function. So this is a one easier question I have taken. Now let's take some algebraic questions also. Okay. So here comes the next question. F is in Q to Q. This is how we read. F is such that Q to Q. This Q is the rational number. Okay. So this is the rational number, and our function is 3x minus 2 is 1 that we have to prove. So our main function is 3x minus 2. We have to prove that it is a 1 function. Now please understand how we will solve. Okay, so you can solve this question with the diagrammatic way also, that means through mapping also. If you consider x is equal to 1, if you consider this is equal to y, so how you have to do? You have to consider that y is equal to 3x minus 2. If you take x equal to 1, you are getting y is equal to 1. If you are taking x is equal to 2, you are getting y is equal to minus of 4. Okay, so you are getting different elements, getting different images. So taking 3 also, just take one more value, 3, 9 minus, no, it will be plus of 4 only, sorry, it will be plus of 4, and here 3 is a 9 minus 2, 7. So you make one mapping, 1, 2, 3 and 1, 4, 7. 1 is related to 1, okay, 2 is related to 4, 3 is related to 7, okay, that is enough. Different elements have different images, hence proved. This function is 1 function. This way also you can do. Now what is the another way, or like in most of the book you will see that way only, because sometimes like you require that criteria or the steps. Okay, so it's better that you most of the time you go with that also, but this is also correct. Okay, you will get full marks. Okay, just represent it very properly, then only you will get. Otherwise if you miss anything, then there may be the deduction of numbers. Okay, so if you talk about this question with another way, so another way is, let us consider x1 and x2 be the two elements which belongs to the our set Q. Q is a rational number, that means whole rational number is to be accepted. So on putting, we need to prove that fx1 should be equal to fx2. So that is fx1 is equal to fx2. We have to take, actually we always start with fx1 is equal to fx2, and at last we need to prove x1 equal to x2. If it is so, then hence proved. So fx1 equal to, every time to prove a function to be 1 function, you have to follow these steps. So fx1 equal to fx2. Let us consider this. So it will be f3x1 minus 2 equal to 3x2 minus 2. As you can clearly see, minus 2 minus, it is cancelled. 3x1 is equal to 3x2, again 3 to 3 also cancelled. x1 equal to x2. If it we got x1 equal to x2 as the result, and so from there you can say f is a 1 function. That's it. Now it depends on you that which method you choose. So likewise you have to solve. Are you getting this? Okay, so like if I take no, let's take another question now. Okay, let's take another question. This is over. Alright, so here a next similar question I'm taking, but there is some difference. See, here in this your f is in the natural number. F is from n to n, that is n is a natural number. Your function is 2x minus 1 is 1 but not onto. Okay, so how we have to see this question if in that way, in that particular way. So again, let x1 and x2 the same. So we have to take fx1 equal to fx2, then putting the things, minus to minus cancel, 2x1 equal to 2x2, again 2 to 2 cancel, x1 equal to x2. So hence f is 1 function. I think this much is clear to you. Now coming to the onto function, you have to mention for 1. Now for onto we are doing the processing. Now understand This is also very important, and whenever you are asked to prove it onto or not onto, the same procedure you have to follow for all the questions. Okay, now for onto, as in the definition, or if you will go back and just remember whatever I said while defining the onto function, you will hear a opposite of 1 1. That means onto is a opposite function of 1 1 function. How? Let's see with the solution here. First of all, we consider y is equal to 2x minus 1. Whatever our fx is there, you consider equal to y equal to fx, or y is equal to 2x minus 1. Now you take this minus 1 here, so it will be y plus 1 is equal to 2x, or x is equal to y plus 1 upon 2. Can we write like this? So I have converted my equation. My equation was in the terms of x. Now I have converted my equation in terms of y. I have reverted. That means y was in fx. Now my x is in fy form. That means what I am saying, previously I have considered y equal to fx. Now I am trying to write x is equal to fy. That means I am going in reverse. Okay. So here you need to understand this thing. Now coming to the moving ahead, as our function is a natural number, that means we always must get the answer or the element. We have to take the element in the natural number, but its image should be also in natural number. Okay, that is why from n to n, that means whatever two sets we are taking this n, so it should be also a natural number. That means these two, the elements here and image here, they both should be the natural number. This should not be violated because our function is in natural number. So here, if ever you put 1 as a result, as a value, so y, if you are putting 1, what x you are getting? So 1 plus 1 divided by 2, 1. Okay, no issues. If you are putting y is equal to 2, just let me know what you are getting. 2 plus 1, 3 divided by 2. So x 3 divided by 2, which is 1.5 or just 3 by 2. But 3 by 2 is not a natural number. It is a rational number or a decimal value. So here this thing is violating the norms of our function. Hence it is not an onto function. I hope the things are getting clear in your mind, that this norm should be satisfied and the definitions should be satisfied. Otherwise this criteria and this criteria is same. For 1 1, this should be proved, and for onto you have to go in reverse, put the values and just check whether it is satisfying the norms of the function or not. I hope the things are getting into your brain, and I believe that you will do more questions of this exercise. Okay, I have only explained you just okay, let's take one more question. No issues. One more question we can take. So dear students, let's understand the last question of 2.3 exercise. See, you have so many things written here, and maybe you won't understand the things, but each and everything has a particular importance in this question. One by one we will understand this one, and this we have to prove. Alright, so I will explain each and everything thing very properly, but first I just want to let you know that this A is a set, B is also set, and your function is from A to B. That means, are you just able to make it out that they are trying to say in such a way, from A to B? Our function is from A to B. Now this A, this is the domain of the set A. Now domain means whatever the values A will take and whatever the values B will take, this is the domain. I guess I have just explained you the meaning of these two. Now again I am explaining you, this R is the real number. Now as real number have all the positive integers, negative integers, 0. That is the whole real numbers. But you have to, the domain of A says the whole real number you have to accept, but -2 should not be there. So accept -2 the whole real number. And the domain of B says except 1 the whole real number. Now what is the meaning? Why we are just leaving? if you can see that your function here in the denominator you have x plus 2. If you put minus 2 here, so minus 2 plus 2 will give you 0, which is an infinite because denominator is 0. So we know whatever denominator is 0, we consider that as infinite or not defined in math. So just to remove, in quadratic equation in 10th class, you have seen equation is given and very close to it they are writing x not equal to 2, 3. So those values should not be kept. If ever we keep those values, will get infinite results. So that is how except minus 2 the whole real number, so you will get the domain. Now this one I will show you in the solution. Okay, now let's start with the solution. We need to prove it is a 1-1 correspondence, means we need to go for 1-1 and onto. So first of all, let us do the processing from 1-1. For 1-1 function, I already told you, you have to take two elements, that is x1 and x2, and we need to equalize fx1 equal to fx2. So let's equalize x1 minus 3 upon x1 plus 2, x2 minus 3 upon x2 plus 2. Take this term here, so you will get x2 plus 2, then x1 plus 2 and x2 minus 3. Now just multiply them. So x1 x2 plus 2x1 minus 3x2 minus 6 equal to x1 x2 minus 3x1, then plus of 2x2 and minus of 6. You can see x1 x2 cancelled, minus 6 to minus 6 also cancelled. Okay, then what else? Okay, so take this minus of this, so 2x1 plus 3x1 equal to there also you send this, so 2x2 plus 3x2, this is a total of 5x1, this is total of 5x2, 5 to 5 cancelled, x1 equal to x2. So we got that this is a 1-1 function. I hope this is clear to you. This is the calculation you can easily do, that's not a big deal. Now coming to the onto function, I told you what you have to consider, this y equal to x minus 3 upon x plus 2. Now take this denominator that side, so x plus 2 into y is equal to x minus 3. Multiply this y inside, so xy plus 2y equal to x minus 3. Now take this 2y that side, okay, and or else take this 3 here and xy that side. So you will get 2y plus 3 equal to x minus xy. Are you getting this? From here we can take x common. Okay, so just wait. Yeah, so 2y plus 3 equal to, taking x common will get x minus 1. Sorry, 1 minus y. Okay, or we got x is equal to 2y plus 3 upon 1 minus y. Now just understand the concept that here in the denominator you have 1 minus y. Now if I ask you to make it infinite, what should be the y? So your answer should be, y should be 1, because 1 minus 1 will give you 0, and in the denominator 0 will get infinite. So that is how they are saying that the domain of this b, that means x is equal to fy formed. So here y should not be 1. That is why the domain says whole real number except 1. Okay. So this is how, this is what we got the onto function. So from here what you have to say, as the domain already given in the question, the domain will be R except for 1. So here, as this domain is matching with our onto, that means this result. So what we have to say, this is an onto function also. So f is 1 1 and f is onto, because as our y belongs to the whole real number except 1. Okay, here talking about this equation, y belongs to R minus this one, and as this is our B, the domain of B, and B is here, and here we say all the different elements must have different images here. So that is how at last we can conclude with this is an onto function. I hope my efforts on the today's video will come up as a fruitful video for you or fruitful thing for you, because you were facing many problems in this. So I hope the things are clear to you now. Now in the next lecture we will take real functions, which is important topic for you. How to find the domain and range of the function. This is what the domain and range. So we'll be going to see them in the next lecture. So I hope you will do the questions. You won't face the difficulty now. Just go through the examples. Okay, I always say to go through the examples because they helps the student more, and also you can learn how to represent the solution. So hope this will help you. And do the practice. The only way to learn mathematics is to do mathematics. Okay, so thank you so much. Have a nice day. Bye bye. Take care.